This video, we're going to talk about matrices. Like a matrix is a rectangular array of numbers. And the example we might have, let's call this one A. And so let's say 2, 4, 3, 1, -7, -8, 3, 6, 2, -1, -3, 4. So this is a matrix. It has 4 rows by 3 columns. And again, it's always described by the number of rows first and number of columns second. So you could have a matrix like this. Let me just call this B. -2, 6, 3, -1, -2, -8. And this is a 2 by 3 matrix. Once again, it has 2 rows, 3 columns. And usually, not always, but usually matrices are designated by capital letters. And again, they're usually designated by, in this form, when they're described the size, it's going to be like M by N matrix. Again, this is always the number, first one's always number of rows. And second one, number of columns. And you can multiply a matrix by a number. So for example, let's say if we have this matrix 4, 5, -3, 7, and we want to multiply it by 3, we multiply every element of the matrix by 3. So it'd be 3 times 4, 3 times 5, 3 times -3, 3 times 7, and that'll give us 12, 15, -9, and 21. Now, notice when we multiply a number by a matrix, the matrix doesn't change size. It started out here, it was a 2 by 2, 2 rows, 2 columns, and it ended up being a 2 by 2, 2 rows and 2 columns. Or if you multiply -6 times this matrix, -6 times this is -24, -6 times 0 is 0, -6 times 1 is -6, -6 times 2 is -12, -6 times 4 is 24, -6 times 3 is -18. Now we can multiply 2 matrices together as well. So let's take a look at that. 2 matrices may be multiplied if and only if the number of columns of the left matrix equal the number of rows of the right matrix. Let me write that down. 2 So that's a necessary condition for two matrices to be multiplied. And so suppose matrix A has size, call it M by N, M rows, N columns, and matrix B has size, say PQ, P by Q, then say A times B is defined if and only if N is equal to P. So, let's say you have something like this. You have A times B. And again, this is saying M by N. And this is a P by Q. These two have to be the same. And the size of the new matrix are the outer two. So these outer two here give the size of the new matrix. So when you take A times B together, if A had M rows and columns and B had P rows, Q columns, the columns of A would have to match the rows of B, and the size of the new matrix would be M rows and Q columns. So let's take a look at some matrices here. So let's say if we said we had, say, something like this. A was 3 minus 1, 0, 4, 5 minus 2, and B was 1, 4, 2, 3, 5, 7, minus 4, 1, 6. So we have these two matrices. And we multiply A times B. And we multiply B times A. So take a look at this. So solution. Again, so what do we have? It has 3 rows and 2 columns. So it's a 3 by 2 matrix. B is a 3 by 3. So if we tried to do this, we took A times B, 3 by 2, 3 by 3, So again, these don't match. So this is not defined, so we can't multiply. On the other hand, let's try B times A. So again, B is a 3 by 3. A is a 3 by 2. And these do match. And the resulting size of the new matrix will be a 3 by 2. So let's actually go ahead and multiply these two matrices. Let's multiply B times A we had up here. Let's take a look at those. So BA is going to be equal 1, 4, 2, 3, 5, 7, minus 4, 1, 6. And A was 3 minus 1, 0, 4, 5 minus 2, like this. So question is, how do we multiply these? So we always start with the left matrix. And first we'll focus on the first row. So focusing on the first row of the left matrix, we're going to take that first row times the first column. And so we're going to take 1 times 3, you multiply them in order, 1 times 3, 4 times 0, 2 times 5. And we add up the sum of those. Then when you're finished with the first column here, again, don't focus on the first row here, go to the next column. And we'll take the first row times the second column. 1 times minus 1, 4 times 4, plus 2 minus 2. Like that. Then when you're done multiplying the first row by all the columns in the right matrix, go to the next row. So next we'll focus on the second row on the left here. Multiply this, go back to the first column here. Second row times first column. 3 times 3. 5 times 0. 7 times 5. Again, I just multiplied each of these. Then second row times the second column over here. So 3 times minus 1. 5 times 4. 7 times minus 2, like that. So now that we've multiplied the second row by each of the columns on the right, we'll go to the third row. Multiply this times the first column. So we have minus 4 times 3. 1 times 0. 6 times 5. Like that. Then we'll multiply the third row by the second column. Minus 4 times minus 1. 1 times 4. 6 times -2, like that. So now we'll go ahead and add up these totals here for each entry. So here we have 3, 0, 10, 13. Over here we have 16 minus 4 would be 12. Minus 1 gives us 11. 9 plus 0 plus 35, 44. -3 and -14 is -17. Plus 20 leaves us 3. Minus 12 plus 0 plus 30 leaves us 18. 4 plus 4 is 8. Minus 12 is -4. And there we have it. As I said before, we were starting with a 3 by 3, 3 rows, 3 columns, multiplied it by a 3 by 2. Again, we said that these had to match to do it, and they do. And then the result was going to be a 3 by 2. And that's what we have, 3 rows and 2 columns. Next, we're going to multiply a matrix times a vector. Now, remember, a vector is just a matrix with one column, is a way to think of this. So, for example, let's say you have something like this to say multiply the vector 3, 2, minus 6 by 1, 2, 4, minus 1, minus 2, 3. And so let's do that. Again, usually we're going to be multiplying the vector on the right of the matrix. So we're going to have here, we'll have 1, 4, minus 2, 2, minus 1, 3. And then we write this vector as a column. And so whenever you have like commas here, this is going to be like a column here, like this. So let's go ahead and multiply this row by this column. Of course, only one column this time. So it's be 1 times 3 plus 4 times 2 plus -2 times -6. Then the next row, 2 times 3 plus -1 times 2 plus 3 times -6, like this. And then let's see, what do we have? This is going to be 8, 3, 11 plus 12 would be 23. And then we have 6 minus 2 is 4. Minus 18 is minus 14. Like this. And again, you could apply the same rule as before. You can say that, okay, here we have a 2 by 3 matrix, and this is actually what, 3 rows by 1 column. And then these match, the middle ones match, so you're allowed to do this. And then the result is going to be 2 rows by 1 column, like that. Now, doing this is going to be useful because often we're going to want to work with systems of equations, and we'll kind of work backwards. So now this time we multiplied the matrices, but sometimes we're going to kind of want to undo things. And let me show you what I'm trying to say here. So for example, let's say if you have a system of equations and we want to write this system minus 7x plus 3y minus z 2x minus 2y plus 2z minus 3x plus 4y plus 4z. Write this as a matrix times these variables. So we want to undo it and write this as a matrix times this. So what you can kind of see, you can think of, again, undoing the multiplication. So you could actually think of this as having this minus, let me write this as a matrix, minus 7, 3, minus 1, 2, minus 2, 2, minus 3, 4, 4, times x, y, z, like this. So in other words, all I did was take the coefficients of x and put them in the first column, coefficients of y in the second column, coefficients of z in the third column, like this. And then took this out. So now, again, let's just check to be sure that I did this correctly. So let's multiply these. Let's go the other way. Check this. And so again, let's multiply this row by this column. We'll have negative 7x plus 3y minus z. And then multiply this row by this column. 2x minus 2y plus 2z. This row by this column minus 3x, 4y, 4z, like that. Now you could also write this in the matrix form, and that would be perfectly legit. But in case, notice that we got back what we started with. This, and this. Again, so this is going to be useful later because we're going to sometimes want to solve this system of equation using matrices, and we want to be able to undo this. So always remember, you can write this by taking the coefficients. You have to be sure you have them lined up correctly. Coefficients of x here in the first column, coefficients of y here, coefficients z right here, like this. We can also add matrices, but 2 matrices may be added if and only if they have the same size. So for example, let's say we have these two matrices, A, which is 2, 0, 1, 6 minus 2, 4, and B, 0 minus 5, 6, 4, 3, 2. Say we have those two. Find let's first find A plus B. And also let's do something else. Let's also find B minus 2A, like this. Again, this is a 2 by 3 matrix. This is a 2 by 3 matrix, so we can combine them by adding them, subtracting, etc. So let's do the first one for A. We want to do A plus B. Again, we're going to simply add corresponding entries. 2 plus 0, 0 plus minus 5, 1 plus 6, 6 plus 4, minus 2 plus 3, and 4 plus 2, like this. And to end up with 2 minus 5, 7, 10, 1, 6. And of course, whenever you add two matrices together, you'll have a matrix the same size as the original. We start out with 2 by 3 matrices, and we ended up with 2 by 3 matrices. Now, the next part here says do B minus 2A. And so let's go ahead and do this. So that's going to be this one here, minus 5, 6, 4, 3, 2. And then minus 2A, that means we're going to multiply this one times 2. And so that means we multiply this matrix by 2. That'll give us 4, 0, 2, 12, minus 4, 8, and then we'll subtract those. So you could, again, we could have done that another way. We could have multiplied this by minus 2 and then added them. What I decided to do, I multiplied this by 2 and then subtracted B minus 2A like this. So if we take 0 minus 4 is going to give us minus 4, minus 5 minus zeros, minus 5. 6 minus 2 is 4. 4 minus 12 is minus 8. 3 minus a minus 4 is same as 3 plus 4, which is 7. 2 minus 8 going to give us minus 6, like this. And there you have it. So we'll take a look at some special matrices, and let's talk about I, which is the identity matrix. And if you multiply, if it's the appropriate size, if you say take A times I, you'll always get the matrix A back. Or if you take A times I on this side, on the other side, you'll once again get the matrix back. And so the identity can be either like a 2x2, and when it's a 2x2, it'll look like this. When it's a 3x3, it will look like this. If it's a 4x4, it'll look like it's etc. And it can be of any size, but it's always going to have ones along the main diagonal and zeros everywhere else. Once again, whatever you multiply it by, assume that whatever you're multiplying it by has the correct size, you'll always get the original matrix back. So for example, if you were to take, let's do an example here. Let's take B times I, where say B is 3 minus 2, 4, 7. And so find this. So B times I is going to be 3 minus 2, 4, 7. And so whenever you see this and it says like B times I like this, it doesn't tell you the size of the identity I, but we'll know from the context. In this case here, since we have a 2x2, this I is going to be a 2x2. That's, you kind of just know it. Whenever you see this notation, okay, this has got to be, I has to be of the size that we can multiply. So let's go ahead and multiply this row times this column. So we get 3 times 1 plus 0 times 2. Then this row by this column, we get 3 times 0 plus minus 2 times 1. Then go to the next row. 4 times 1 plus 0 times 7. Then multiply the second row times this last column. 4 times 0, which is 0, plus 7 times 1. And we have 3 minus 2, 4, 7. So whenever you multiply something by the identity, just with real numbers, you always get the original object back. In this case, we get the original matrix back. And also we have the zero matrix. And whatever you take the zero matrix by, you always get 0. So in other words, if you take A times the zero matrix, you get the zero matrix back. Or if you take 0 times A, you get 0. Again, the zero matrix is going to be, maybe a 2x2 or a 3 by 3. Or 4 by 4, etc., whatever size you want. And just like before, of course, if you take, say, let's use the same matrix B that we had. 3 minus 2, 4, 7. Then B, say, times 0 is going to be 3 minus 2, 4, 7 times 0, 0, 0, 0. And again, 3 times 0 plus minus 2 times 0 is going to give us 0, 0 plus 0. Then if we take same thing over here, same thing over here, same thing over here, and we end up with the zero matrix like this. So the matrix, zero matrix times anything will always give you the zero matrix back.